Hello, astronomy meteorology students. It's Mr. Johnson here with the final video on characteristics and properties of our atmosphere. This video is going to be covering humidity. Remember, taking notes is a great idea. You can always pause and rewatch the video if necessary. So to get us started talking about humidity, I'll remind you that there are two basic processes. There's condensation and there's evaporation. And water is continually going back and forth between the atmosphere and the earth. Evaporation is going from a liquid to a gas. Condensation is going from a gas to a liquid. Now, if there is more evaporation than there is condensation, the water vapor in the atmosphere increases. In other words, if we have more liquid water turning to gas than we do water vapor turning to liquid, then we are going to have more humidity, a higher amount of water vapor. Eventually, if there is enough evaporation and not enough condensation, then it is possible to max out the amount of water vapor in an atmosphere, or in that part of the atmosphere. And we'll talk about what that means in just a minute. But the key to this slide is to remember that we can have liquid water going to vapor, that's evaporation. We can also then have water vapor turning to liquid, that's condensation. And it's just a matter of the balance between the two. If we have more evaporation, then we have an increase in water vapor. If we have more condensation, then we have a decrease in water vapor. And all humidity really is talking about the amount of water vapor in the atmosphere at a particular place. There's three ways we can refer to humidity. We can talk about the absolute, the relative, or the specific. And so the absolute would be if we were to look at one particular given volume of air. The absolute humidity is the number of those particles in that area, the number total of the water molecules. In other words, the number of grams of water. Relative has to do with how much humidity is in the air compared to how much the air can hold. And then the specific has to do with how much water vapor is there in an area compared to how many other things that are in the area in terms of particles. So we're basically looking at the amount of water vapor compared to all of the other stuff in the air. Now, humidity can increase with temperature. If we have colder air, it can hold less water. Warmer air can hold more. And the key has to do with space between particles. Remember, warmer air spreads out, so it's less dense, which means that we can fit more water vapor into that air. Cold air is more dense, it's packed together tighter, so there's less space between those particles for water vapor to be. Now, humidity is typically represented in two ways. It's usually reported as either relative humidity or sometimes referred indirectly as dew point. So if you've heard of relative humidity and dew point and don't know the difference, my goal here is to help you understand those right now. But again, humidity is expressed in both relative humidity and dew point. Usually people look at relative humidity. My goal today is to tell you or to convince you that dew point is maybe more helpful. To talk about relative humidity, relative means a comparison. So really what we're doing here is we're comparing how much water vapor is in the air compared to how much could be in the air. So when we say, oh, it's 95% humidity today, what's it going to feel like? Well, it really depends on the temperature, because 95% humidity when it's cooler out, well, cold air can hold less water, so that's not very much liquid in the air. Whereas if we have warmer air, 95% humidity, well, that's a lot more water that's going to be in that type of air. So in other words, with relative humidity, what we're looking at is we're looking at how much is in the atmosphere in terms of water vapor compared to how much that air can hold. We show this as a percent. And again, that percentage depends on the temperature. So warm air can hold more water vapor, cold air can hold less water vapor. So if we were to have, if we were to have a fixed amount or if we were to have, a consistent temperature, then we can change the humidity by having more evaporation, increasing the humidity, or more condensation, decreasing the humidity, if we were to keep the temperature the same. But remember, we could have the same amount of water in the air, and if we increase the temperature of the air, the particles of the air will become less dense, and so there's more space with the same amount of water. The percent humidity would have gone down. The opposite is true. If we were to take the air with a set amount of water in it and cool it down, all of those particles will condense together. That cold air can hold relatively less water, and that would cause the water vapor, or the relative humidity, to increase. So again, going back to relative humidity, if you look at the forecast and it says that it's going to be 80% humidity today, well, that's not very helpful. If it's 110 degrees out, then 80% humidity is going to be really hot, because there is a lot of space between molecules in air that's 110 degrees. And so if you fill 80% of that space, that's a lot of water vapor. But if you have colder air, let's say it's like 50 degrees out, if you have 80% relative humidity, then that's basically saying that 50-degree air is a lot more compacted together, which means that there's less space. So 80% of that smaller space is less liquid. It's going to feel less humid. So let's talk about dew point. Dew point is saying that there is a certain amount of liquid in the air. What temperature would we have to cool that air down to reach the point where things are saturated? Because once the air is saturated, dew forms. You've noticed that sometimes in the morning, dew will form on the grass. Well, that's because you have a set amount of water vapor in the air. There's only a certain amount of water vapor in the air, and that doesn't change. But what does change is the temperature. It cools down to the point where dew can form. It cools down to the point where there is not enough space between the molecules for the water to actually stay suspended. And so the water will clump together and form, it'll clump together and attach to surfaces like grass. Now, dew point is shown as temperature. So you could go online right now and you could search for the dew point as we speak. Now, when the temperature and the dew point are the same, that condensation occurs. And that condensation can either, like I said, come in the form of dew or frost in the morning. And I'm not talking about ice, I'm talking about frost. Now, what does that mean? Well, the closer these two numbers are, the dew point and the temperature, the more humid it will feel. So what I like to do when I go on and look at the weather, I don't bother with relative humidity. Instead, what I do is I look at the dew point. If the dew point is 50 degrees and it's 90 degrees out, well, that's a big difference. That means that we'd have to cool that air down to 50 degrees in order for the condensation to occur. So again, if dew point is like 50 degrees and it's 90 degrees out, it's going to feel hot, but it's going to be kind of that quote unquote dry heat. However, if we have it 70 degrees out and the dew point is 65, then that's only decreasing by 5 degrees before condensation happens, which means that 70 degrees will actually feel really, really humid out. Temperature can't drop below the dew point. If you think about it, as the temperature reaches that dew point, that air is now saturated with water. The water will cling together and stick to things. So as you cool the air down and it reaches the dew point, what will essentially happen is that the air is sort of wringing itself out. That water will clump together, stick to things, and the humidity will become less. There will be less water vapor in the air. Now, this idea of dew point and temperature, they will combine that together, and by they I mean weather stations will combine it together and report it as the heat index. The reason that is when the dew point and the temperature are close together, then that means that the air really can't hold that much more water. So when you sweat, that sweat has nowhere to go, and it will feel even hotter because sweat is the way that your body cools down. And so if your body doesn't have the ability to lose that, and have evaporation occur, that evaporation is taking the heat away from you. So if the evaporation can't happen from your body, like the sweat can't leave because there's too much moisture in the air, then you don't have any way of cooling off, and it's going to feel a lot warmer. So heat index has to do with the relative humidity and the temperature. It's saying how much water vapor is there compared to how much that air can hold. I'm going to leave it there. There's a couple ed puzzles to watch. Please make sure that you take the time to do that. Reach out with questions. This dew point, humidity, heat index, all of this stuff can be kind of confusing. So please ask me for questions. I might make a second video to highlight those again if I need to. The key here is it's all about the size of the container. And by that, I mean warm air is essentially a bigger container. Cool air is kind of a smaller container. And so 50% of a big container, warm air, that's a lot more water vapor. 50% of a smaller container, cold air, is a lot less water vapor. Anyway, reach out to questions. Thanks for watching and have a nice day.